Again, Chris Good here, and let's wrap it up. The practice t-tests number 5. You're interested in how well each team has learned to run. You randomly assign your players to 2 teams. Team C trained with shoes. Team D trained with boots. I wonder who's going to win. Let's see. The number in the columns below are the minutes needed to run around the track one time. Alright, so I have actually calculated means and degrees of freedom here for these, and there's a slight mean difference here. Let's see if it's significant or not. Let's do our null hypothesis statement. The null hypothesis is that mean 1 minus mean 2 is 0. Step 2, alpha 0.05, and we will use a two-tailed test. So our critical value for T with 10 pooled degrees of freedom, see I already pooled our 6 scores in each one, 5 degrees of freedom each is 10. And we'll go ahead and look up for 0.05 and two tails combined, 10 degrees of freedom, 2.228. It's two-tailed though, so we're going to do plus or minus 2.228. Alright, step 3, calculate T. We know that we need to start with our sums of squares. And last video, in video 4, we saw how to do sums of squares just using scores and squared scores in one formula. So if we square all these scores, right, we can actually write this long formula. It's the sum of the squared scores. Let's go to the formula sheet. The alternative sum of squares equation, the sum of x squared minus the sum of the scores, sum of x, that's this part, divided by the number of scores. I gotta close parentheses. Nope, all parentheses are closed. Alright, that's sum of squares 1. That's sum of squares 2. And we can go to the head to the pooled variance here. Alright, and that's equal to sum of squares 1 plus sum of squares 2 divided by degrees of freedom 1 plus degrees of freedom 2. And that means we can now get the estimated standard error, which is the square root of first pooled variance over n1, then pooled variance over n2. That's our estimated standard error, which means that T is the difference between your two means, mean 1 minus mean 2, divided by estimated standard error. We're going to need a decimal. Let's align these all right and clean things up just a little tiny bit. Okay. What's our appropriate decision here? Well, let's go to the t-table. Alright. 2.228 was up here, 0 is here, negative 0.228 here, and t in this case is 0.240, so it's actually close to 0 on the positive side. Definitely not in the shaded area, so we'll fail to reject. We'll retain the null hypothesis, and what was the original question? How fast are people running? How many minutes does it take to run around the track once? So, people wearing shoes did not run significantly faster than those wearing boots. And we know this because the t at 10 degrees of freedom was equal to 0.240 with a p greater than 0.05. We don't know what lies beyond, what proportion of area under this curve, right? Proportion is probability. What proportion of area under the curve lies beyond a value of 0.240? We don't know, but we know that it's more than 0.05 because it wasn't in the critical region. That's it. And we're done with the practice t-tests.